Hi, my name is Daniel Monforti. I'm an application engineer with Regal Technologies, and today we'll be expanding our power management video to show some additional testing possibility that Regal provides. We'll be performing the same three tests, a nominal power, boot up energy, and peripheral performance test, but we'll be using our electronic load to simulate the IoT board's performance during these tests. For our first test, we'll be performing a nominal power test. In order to do this, I've created a simple script on our IoT board where all it's doing is turning on some LEDs just on the board. And what we're going to see on our oscilloscope is different current levels being drawn over time as different number of LEDs are turned on. And what we're going to do is try and duplicate this same sort of current draw pattern with our electronic load. So in order to reference this for later, I'm going to first set a reference. And once it's saved, I'm going to move the leads over from the IoT board to our load just to replicate the power that the IoT board is drawing from our battery. And now that our leads are moved over, I've already pre-programmed our load with in the list function just to give us our 6 steps that we had at our different thresholds. And I'm just going to walk through what I did. So basically what I've already done is I put it in constant current mode right here. I've set the number of cycles just to 100, and then I've done 6 steps just because there's 6 steps on our in the current draw in the from the IoT board. And what we're going to see on our steps is we'll increase our amperage. So the first one is at 10 milliamps, then 20 milliamps, then 30, and then 40, and that's going to come back down to 30 milliamps. And then our step number 6, which will be 20 milliamps as well. And what we're also going to see is our duration. They're going to last about half a second for each one for our sort of step level, and then it's going to increase, and it's just going to loop back. So in order to turn this on, you first hit on, and then you basically hit the transient button. And at this point, we'll see both on this display in blue, basically move through the different steps, and we'll see it just keeps cycle. And just like on the load, we can see on our scope the different steps, and it's not quite as much as our it's a lot more distance than our reference, but we're still seeing the noticeable steps, and they're all lasting half a second just like our reference. We monitored the basic current consumption of our IoT device with a DS4000 oscilloscope and an RP1000C current probe. The next test that we will be performing is a boot up test where I'll be capturing the current and voltage spike that is generated when the IoT board is switched on. Once we know what this looks like, we'll be able to mimic it with our electronic load. To begin with, I will trigger my IoT board to switch it on. As we can see, we've got a large current spike here and a small voltage drop here. And we can see that it's represented with the yellow line shown here. And on channel 2, we're measuring our voltage, which is shown here in the blue line. Now that we know what this will look like, I'm going to go over here and hit save to save a reference. I'm going to remove the probes off the IoT board I have, and I'm going to hook them up directly to the load. Now that they're hooked up, I'm going to be using our pulse function. From there, I will enter in the relevant values to mimic the values generated by the IoT board. And let's hit OK. And I'll just hit apply. Now in order to trigger the load, I'm going to first turn it on, and then I can trigger our current draw. As you can see with our load, we're able to pretty closely replicate our current spike there and our current draw. To emulate this boot up pulse, we set the electronic load in pulse mode to create a high-speed shaped pulse, similar duration and amplitude to what we captured using the IoT board. We can test the battery drain of repeated restarts using our electronic load. For our final test, we'll be looking at the current draw when SPI commands are sent from our IoT board. Now, as we can see on the screen, we can see that there's large portions of flat current being drawn, along with some periodic spikes being drawn as well. And our flat portions are offset quite a bit from our 0 point, so there's quite a bit of vertical offset on our reading as well. Now, when we try to take this into account with our load, we're going to have to take into account both a linear shift up due to the offset, along with the spikes individually. So first, what I'm going to do is I'm going to set a reference, and we're just going to save it. And we can see our reference right behind the signal. Now that we have a reference, we're going to move on to our load. The first thing that we're going to do is we're going to hook up our battery to our load and disconnect the IoT board. Now that's hooked up, we're going to go into the continuous mode. Now that we're in the continuous mode, we're going to start setting levels just like before in our previous test, and then we'll just hit apply. Now we're going to turn on the load, which is going to give us our vertical shift, but we also have to turn on the spike, so we're going to hit the transfer function, and we'll have to adjust our trigger a little bit. We're not quite perfect with our current floor, but we've certainly brought it up, and we're more close on the top, but we've also got our spikes which are better matching the spikes from before. By using an oscilloscope and current probe, we are able to measure the change in voltage and current over time, and then use an electronic load to emulate a similar power draw. By using electronic load, we are able to simulate an ideal and non-ideal voltage and current draw over time. Together, these instruments make up an affordable package for IoT testing.